Hello guys, so today I'm going to talk about what is an state diagram and what does it do. So state diagram is used to represent the condition of the system or part of the system at finite instance of time. It's a behavioral diagram and it represents the behavior using finite state transition. State diagrams are also referred as state machines and state chart diagrams. These terms are often used interchangeably. So simply a state diagram is used to model the dynamic behavior of a class in response to time and changing stimuli. We can say that each and every class has a state, but we don't model every class using state diagrams. We prefer to model the states with 3 or more states. A state diagram, this is an example of a state diagram. This is how it starts. Card swiped, waiting for pin entered, pin rejected, pin verification, pin authentication, user identified. This is a small state diagram example, like for an ATM. That's we have a video. And the basic components are initial state. We use a black field cycle to represent the initial state of system or a class. This is what he's talking about. Initial state is the start. And in transition, we use a solid arrow to represent the transition change of control from one state to another. The arrow is labeled with event, which causes the change in state. So this is what he is talking about, this arrow. And for state, we use a rounded rectangle to represent the state. A state represents the condition or circumstances of an object of a class at an instant of time. So this is what it is that we have told you. And fork, we use a rounded solid rectangular bar to represent the fork notation with incoming arrow from the parent state and outgoing arrows towards newly created state. We use the fork notation to represent the state splitting into 2 or more concurrent states. And join, we use a rounded solid rectangular bar. Rounded solid rectangular bar. This is what we're talking about. To represent a join notation with incoming arrows from the joining states and outgoing arrow towards the common goal states. And concurrently converge into one of the occurrence of an event or events. Self-transition is we use a solid arrow pointing back to the state itself to represent the self-transition. There might be scenarios when the state of object does not change upon the occurrence of an event. We use self-transitions to represent such cases. So this is a state diagram for a hotel management system. We have built this upon a question actually. So this is the scenario. Suppose you need to develop a hotel management system. Draw a state diagram for hotel management system using state diagram symbols and details. So this is we have built a state diagram for a hotel management system. So like this is how it goes, as if like we talked about all these circulars and all the rectangulars that we use for off and reservation and all the stuff. So these are like hotel room categories or all the like main characters. When it splits, split with the circle. So that's how it goes normally. As if you can see for the hotel management system, this is how it normally goes. It starts from the customer, payment, check-in, reservation. When you do all the reservation in hotel IDs and all the stuff, room category and room, and checking out what's the date, it has been, if the payment has been done, the invoice has been received, and all the bills and stuff. That's how normally a state diagram for a hotel management goes.